right, let's go ahead and do a few more examples. I am going to switch to pink now. We are asked to find the domain of this given function. So we have g of x equals the natural log of 1 over x plus 9. So I am taking the x plus 9 over 1. Okay, so I'm setting this equal greater than 0. My focus is in the denominator of this. So I have x plus 9 greater than 0. Solve for that. When x is greater than -9. Write that in integral notation. And that will be my domain. Now let's see if that is correct. Okay, it's correct. We're given a good job. So we are going to the next one. And then this, so this is for us to graph it. Oh, let me see. Okay. All right, so this is for us to graph it. And in the options, we are given certain options. So we only need to worry about whether there is a vertical, horizontal shift. Okay, so we know that we are starting here at 1. Okay, the graph is kind of small. Oh, there we go. So this is how the graph looks when it's not as tiny. Okay, so let's see our options. Okay, so we have log base 3, 1 minus x, given the x is negative. That's not one of our options. That's not what matches what we have right here. Okay, on the screen you cannot see all of them. I see, not good. Ooh. So it moved horizontally, all right, and it moved 1 horizontally. So if I move, so I know it's positive, so my x is positive. So any choices where my x is a negative, I eliminate, all right? And then my movement is horizontally, so that is inside the parentheses, inside the log, all right? Nothing outside. So out of the choices that I have, this one is the one that makes the most sense for my graph right here. Let's go ahead and check that. Now, what I want you to do is when you have, before you check, go ahead and graph this and compare what you get in your graphing calculator to the given graph that you have right here. Okay, let's look at another example. Okay. So I'm just going to open it up so you can see a little bit better. Okay. So the other one was right here at 2. Now we're there at 1. Okay. And we're still in, our x is still positive. So any choices that our x is now positive, we eliminate. And then remember for the logs, how do you get out of here? For the logs, we start with 1, all right? So this was already a 1. There's no movement happening here. This one didn't move or anything. It started right there where we always start, okay? So again, take this, graph it, and compare, all right? And again, there was no movement. There was no vertical or horizontal movement, okay? Okay, are we doing this one? What number is this? Okay, we did some examples like that in class. So we are going to go to 17. Okay. Okay, so in class, when anytime we were solving this logarithmic functions, we change them from logs to exponential. And then when we change them from, after we change them to exponential, we use our rules of exponents so they have the same base, so then we can solve, okay? But here we have e and we have 5. So this is in exponential form, and it's like, okay, so how am I going to have the same basis here? for cases like this, we have the natural log, which is ln. So if we take the ln on both sides, the ln cancels the e. So we'll have ln of e to the 3x, okay, equals ln of 5. This and this cancels, leaving you with your 3x equals ln of 5. Again, we are solving for x, so I'm just going to do that division right there. Ln of 5 over 3, okay? And this, in your calculator, you do have the symbol for ln right under log, right? So if you were looking for exact values, because think about this is like an approximation, okay? So it just wants a solution. So we're just literally typing in, let's use the fraction because we're having a fraction here. So we have ln of 5 parentheses 3. I don't think you need to use a parentheses, but let's just check. Yeah, so that would be good. The next one we'll do, let's see, maybe let's try it without the parentheses. Okay. Oh, we might need a parenthesis for the next one, so let's go to the next right here. So we are doing the same. I'm just going to go ahead and to write it right here. Equals 5. So we are taking the not. Oh, it was the other one 5 too? I think it was 5. So we are using the natural log. And this is just to cancel the e. Okay. Bye-bye e. I have my 3x plus 2 down. Natural log of 5. Again, I'm minusing the 2 right here. Minus the 2. Because my goal is to what? What is my goal? My goal is to solve for x. So that's what I am doing. Yeah, the parentheses are needed here to make sure you don't confuse natural log of 5 and include that negative 2 inside. We do not want that. Okay. So this is natural log of 5 minus 2 over 3. And let's go ahead and type that in. We have our parentheses at the top. I have natural log of 5 minus 2 divided by 3. I feel like the other one was a 3 too. Like the other one was a 5 and a 3. Okay. Okay. We need to next. Okay, thank you. So we have 5 e to 0.5 x equals 7. Okay, so before we do the natural log to remove the e, right? So they can cancel each other. The e has to be by itself. So I need to divide by 5 first. Because why am I dividing by 5? Because the e and the 5 are multiplying, and the opposite of that is division. Okay, so then I'm going to do the natural log of e to the 5x and natural log of 7 over 5. My natural log cancels my e. So what is in the exponent comes down. And I am left with 7 over 5. And now I just divide. So, and it's going to look a little, because it's like a fraction divided by a decimal. But yeah, that's it. If you type all this in your calculator, you will get a decimal, okay? But they don't want us to do that. They just want us to use like exact answers, So they're not asking us to some round or anything like that. So we are not doing that. We are typing in exactly what we are getting right. Oops, not that. Exactly what we're getting right here. 0.5. Did I type that in correctly? It looks, yeah, let's check. Okay. Yay. And I think that's what I wanted it to do for this video.